While we previously talked about solving using the substitution method, we'll now look at another method called elimination. The substitution method is very efficient. However, there are many cases where using this method will introduce fractions almost immediately. So while you can still get the solution, most students don't like to deal with fractions, so we try to avoid them whenever possible. And the elimination method is going to allow us to solve these types of problems. The elimination method has three basic steps. Step one is to adjust the coefficients. In order to do this, we're going to multiply one or both of the equations by a non-zero number so that the coefficient of one of the variables in one equation is equal to the negative of the coefficient in the other equation. So I need something like a 2x and a negative 2x, or a 7y and a negative 7y. Step two is then going to be to add the two equations together. And this is going to eliminate one of the variables because I have something like 2x minus 2x. And then we can solve the remaining equation. And then step three would be to back substitute. Once we have step two, we have one of our variables. So we substitute that value that we just found back into either one of the original equations and solve. So let's look at some examples. We have the system 3x minus 2y equal to 4 and negative 7x plus 4y equal to negative 6. So we need to start by adjusting the coefficients. And we can see that if I multiply the first equation through by 2, I would have a negative 4y, and then my second equation will have a 4y, which is exactly what we need. So I'll multiply my top equation by 2, and I'll leave the second equation alone. When I multiply the top equation through by 2, I get 6x minus 4y is equal to 8. And now that I've adjusted, I can add these two equations, and I can see that my y term is going to cancel. On the left-hand side, 6x minus 7x is negative x, and on the right-hand side, I have 8 minus 6, which is 2. Dividing both sides by negative 1 gives us that x is equal to negative 2. Now that I have that, I can substitute it back into one of my original equations. And I'm going to use my first equation. My first equation said 3 times x, which we just said was negative 2, minus 2y is equal to 4. Simplifying that gives me negative 6 minus 2y is equal to 4. I then need to add 6 to both sides. When I do, I get negative 2y is equal to 10. We can then divide both sides by negative 2. And when we do, we get y is equal to negative 5. So I now have my solution of negative 2, negative 5. Let's look at one more example. This time I have 2x minus 5y is equal to negative 3, and negative 3x plus 4y is equal to 8. I'm not going to be able to multiply a single equation by a number in order to get things to cancel, so I'm going to have to multiply both equations. So in order to do this, we need to decide if we want to eliminate x or y. Since we eliminated y in the first example, let's eliminate x now. In order to do that, I'm going to multiply the first equation by 3 and the second one by 2. The first equation gives 6x minus 15y is equal to negative 9. And the second one gives negative 6x plus 8y is equal to 16. And now I have these coefficients which are negatives of each other, which is what I wanted. When I add these together, the x's cancel, and I'm left with negative 7y is equal to 7. We can divide both sides by negative 7 and get that y is equal to negative 1. Now that we have our first variable, we need to substitute this into either one of our two equations. Since we used the first equation last time, we'll use the second one this time. The second equation said negative 3x plus 4 times y, which is negative 1, is equal to 8. Simplifying gives us negative 3x minus 4 is equal to 8. We can then add 4 to both sides, which gives us negative 3x is equal to 12. We then divide both sides by negative 3. And when we do, we get x equal to negative 4. So my solution is negative 4, negative 1.